We're covering battery management and its impact on flight time, a critical topic for your FAA Part 107 exam. The exam will test your understanding of lithium polymer or LiPo batteries, not just as a power source, but as a crucial component affecting safety and mission planning. Let's start with cold weather operations. LiPo battery performance degrades significantly in cold temperatures, generally considered below 50 degrees Fahrenheit. The cold slows the chemical reactions inside the battery, which increases internal resistance and reduces its ability to deliver power. An exam question might present a scenario where a pilot plans a flight in 40-degree weather. The key takeaway is that the flight time will be dramatically shorter than in mild conditions, potentially by 30% or more. A common trap is underestimating this reduction. The exam expects you to know that preheating batteries to room temperature, around 75 degrees Fahrenheit, is a critical safety procedure. You should also let the drone hover for a minute after takeoff to allow the battery to warm up further under its own load before proceeding with the mission. Next is the concept of voltage sag. When the drone's motors draw a large amount of current, like during a rapid ascent or while fighting strong winds, the battery's output voltage will temporarily drop. This is normal, but it can be alarming if you're not expecting it. The exam tests this concept in the context of responsible power management. This is why you must always plan to land with a power reserve, typically between 20 to 30%. This buffer ensures you have enough power to safely return and land, even if you encounter unexpected headwinds or need to perform a go-around. The exam will frame this as a judgment question, testing whether you, as the remote pilot in command, are making conservative and safe decisions. A major safety topic is battery damage. You must inspect your batteries before every single flight. If you see any sign of swelling, puffing, denting, or casing damage, that battery is a significant fire risk and must not be used. The exam will present this as a clear-cut safety choice. There is no acceptable level of damage. Any compromised battery must be taken out of service and disposed of properly. The trick answer might suggest using a slightly puffed battery for a short flight, which is always incorrect. The risk is a thermal runaway, which is an uncontrollable and violent battery fire. Also, remember that LiPo batteries have a finite lifespan, degrading with each charge cycle. A battery that is a year old with 100 cycles will not provide the same flight time it did when new. When it comes to long-term storage, a LiPo battery should be kept at about 50 to 60% charge, which is around 3.85 volts per cell. Storing a battery fully charged or fully depleted for an extended period will permanently damage it and reduce its lifespan. Finally, let's discuss the manufacturer's advertised flight time versus real-world performance. This is a classic exam trap. The 30-minute flight time on the box is achieved in perfect, windless lab conditions with no payload. Your actual flight time will always be less. The Part 107 exam expects you to know that factors like wind, cold temperatures, aggressive flying, and carrying any payload will reduce your flight time. A question might state the manufacturer's spec is 28 minutes and ask for a realistic flight time in 15-knot winds. The correct answer will be significantly less than 28 minutes, as a mental shortcut. Remember the phrase, plan for reality, not the rating. This reminds you to always base your mission planning on actual conditions, not the best case number on the box. For free practice questions, AI-powered explanations, and more exam prep tools, visit openexamprep.com. That's openexamprep, all one word, .com.